Hi friends, welcome back to Edupedia world. In the last lecture we discussed about three concepts: free, forced and damped vibration. Today we will discuss about a special case of forced vibration. Under special conditions it happens, and that is known as resonance. We'll see what resonance is, the condition under which resonance occurs, and to sum it up we'll discuss some examples on resonance. We discussed in the previous lecture that an interesting phenomena occurs under special circumstances of forced vibration, and we named it as resonance. So today we will discuss the specifics about it. Resonance. As we have discussed previously, that during free vibration a body has a frequency which is inherent to it, and that is called as natural frequency. In case I did not mention in the last class, natural frequency. This is the inherent frequency which every body has, and it is a specific frequency which is natural to it. So if a body were to freely vibrate and we were to observe the frequency at which it is vibrating, it would always vibrate at its natural frequency. Okay, so this is a phenomena under free vibration condition, natural frequency. Now what is resonance? Resonance is when the frequency of the external force, frequency of the external periodic force is exactly equal to the natural frequency of the body, natural frequency of the body, then the phenomena of resonance occurs. And when the phenomena of resonance occurs, what happens is the body starts to vibrate with increased amplitude. Body starts to vibrate with increased amplitude. So the periodic frequency of the external force becomes equal to natural frequency. Under that condition, the body starts to vibrate with very, very high magnitude, increased amplitude, and that phenomena is known as resonance. The vibration of large amplitude that is caused are known as resonant vibrations. So the vibrations are called resonant vibrations. Okay, so this gives you an idea about what resonance is, and to help you understand the concept, think about this. Think you are in a swing and you are swinging, and each time you are at the backmost point and you are just about to start moving forward, a friend of you starts to push you, and this happens in each cycle. Whenever you reach the backmost point and are just about to go forward, the friend keeps pushing you. What will happen is that the amplitude or the degrees by which you will swing will keep on increasing, and that will keep on increasing quite quickly. So this is a situation where your natural frequency, that is your swing frequency, is being matched by your friend who pushes you every time at the same position. Therefore, he syncs his frequency with your natural swing frequency, and as a result, resonance happens and your amplitude of vibration will keep on increasing pretty significantly. Okay, so this example might have helped you figure out what is exactly happening during resonance. Now let us discuss some properties of resonance. We have already seen the definition and what is happening. Some of the properties of resonance will be as first is that the external periodic force frequency should be equal to the natural frequency. Amplitude is very large. That is a consequence of resonance. Third, the vibrations are in phase with the external periodic force. What does in phase mean? That is, they both are like, as in the case of swing, whenever you are about to go down, the friend is pushing you further down. So they are in sync, in phase. And finally, during forced vibration, once you stop the external force, the body will come to rest quite quickly. But that is not the case in case of resonance. If a body has been put to resonance and after that you stop the external force, the body will take a lot of time to come back to its stagnant state. So these are some of the properties and phenomena related with resonance. Next, I will discuss a few examples where resonance takes place in real life. Here we have some examples of resonance. The first is sympathetic vibration of pendulum. What happens is, suppose you have two pendulums hanging side by side. This is, let's say, pendulum A, and this is pendulum B. Now, to begin with, pendulum B is kept standstill and pendulum A is given some vibration such that it vibrates about its mean position. You will notice that after some time the pendulum B also starts to vibrate, and the vibration of the pendulum B will be in same phase as pendulum A. So what is happening is basically A is setting the pendulum B into vibration via resonance. Since they are quite similar, the natural frequencies are same, and this frequency of pendulum A is transferred via pressure difference to B, and that is setting B into vibration. Okay, so this is known as sympathetic vibration of pendulum. Second, resonance in machine parts. An example we will see is in vehicles. You must have noticed that at certain speeds the vehicle starts to vibrate very rapidly. There is a lot of jerking in the vehicle even though the road is quite smooth. That is the position where the vibration of the external vibration of the vehicle meets the natural frequency of the vehicle, and as a result the vibration becomes quite large. So if you change the speed a little, if you increase or decrease the speed, then the resonance state is broken and the vehicle will start behaving properly again. So it's important that the machine parts, nothing is, no bolt, no screw should be loose, everything should be tightened, because sometime or the other resonance is bound to occur, and if everything is not tight enough, then that resonance can displace things and it can bring the machine to a breakdown. Third, resonance in a guitar. Guitar, as you might have noticed, has set of stressed strings, but those stressed strings are not independent. They are bound over a box which is known as a sound box. Now you might think, what is the purpose of a sound box? The matter of fact is that if the stressed string were a long plate, then they would not produce sufficient noise for someone to hear it. Only someone very close to the guitar could hear it. But what the sound box does is that the vibrations from the string is passed on to the sound box, which has a very large surface area, very large volume, and the stressed string and sound box are such that their natural frequency are same. What happens as a result of this is that the sound box, being of large volume, and since the natural frequencies are same, they start to vibrate together. The sound box also starts to vibrate at resonance, and that leads to a loud sound being produced. Okay. Now finally, the resonance in a bridge. Bridges have a natural resonance too. Every material has a natural resonance. So suppose you might have heard that army troops, while crossing bridges, are asked to break their step. That is, the army personnel are said not to walk in sync. If they walk in sync, what might happen is that each army personnel is exerting some force on the bridge, which results in some vibration, external forced vibration. And if everyone is in sync, and somehow it happens that they are in sync at the same frequency as that of the bridge, then their steps can create a resonance in the bridge, and that might actually lead to the collapse of the bridge. Quite dramatic, but it can happen. So as a precautionary measure, army personnel are asked to break their step while crossing a bridge. In fact, there has been scenarios where a bridge has collapsed due to resonance created by the wind. On a particular day, it so happened that the wind frequency, the frequency of the wind, matched exactly the bridge frequency, and the bridge collapsed like a deck of cards. You might want to Google it up for this incident. So these are some examples of resonance. I hope the theoretical part and these examples with the previous understanding of forced vibration gives you a complete picture about what resonance is. I'll close today's chapter at this note. We'll meet in the next class. Till then, have a great day. Goodbye.